Good afternoon, everyone. I hope everyone is having a good time, learning a lot of new things at Black Hat. Cool. Not feeling sleepy? No? All right. So we're going to learn a few things important today. So I would recommend everyone who are sitting in the back and are not able to see the slides, please feel free to come forward. So today we are here to talk about a very interesting topic, permission explosion. I'm sure we have seen this somewhere in our companies at some point in our career. And what we'll be sharing today can be used in AWS, but a lot of other tools that you have in your company. So it's not specific to AWS. The techniques that you will learn today, you can apply it to any tool or any platform. I am Pankaj Moolrajani. I lead security engineering team at Motive. These are my contact details if anyone wants to get in touch. But a little bit about me. I love creating software that solves real human problems. This is a photograph of me nearly 10 years ago when I started learning how to write code. And this is where I'm learning how to create a data center setup. Back in the days, AWS and other cloud providers were not very popular, so we had to learn how to set up data center, and this was an interesting time. I also love Indian food. As you can see, this is a photograph of me and my wife celebrating my birthday, and I cannot just take my eyes off the food. I'm just waiting to get started. I also love taking long walks in a nice weather. It makes me feel good and clears my mind. And that's why I live in San Francisco, California. Even though the tax rate is very high there, but I like to think of it as I'm paying a weather tax. That's the only way I can justify it. All right, cool. So what are we going to learn today? We're going to learn about permission explosion, how to identify, how to fix it, and how to keep it away once and for all. A little bit of sneak peek, what we'll be learning today. So this is the environment of Motive, and the graph looks very messy, but I'll explain it to you guys. The orange dots that you see here are the roles. It's the subset of our environment. We have taken 5 roles to explain the content of this presentation. The red dots present the roles that we have in the company. Some companies call it as groups, some companies call it as roles. And the blue dots are actually the permissions that exist in AWS in our environment. And the blue edges are actually showing what permissions are assigned to what roles. Today, after following the few techniques, you will see that we were able to reduce number of permissions in our environment by 63%. And there are simple 3 techniques that we use. We'll learn all about that today. Before we jump into the fun stuff, let's get some basics cleared. What is a permission? Let's take an example. Bob is a user having a developer role. And this developer role gives Bob the right to delete a specific database instance. This right to delete the specific instance is actually called permission, a user's right to perform a specific action on specific resource. So I want you guys to focus on 2 things here. A permission is made of 2 components. One is the action, and one is the resource. Specific action on specific resource is actually a permission. These permissions are then assigned to a role, and the role is assigned to the user. And that's how the permission management in big companies and big platforms work. So today we'll be focusing on how to identify permission explosion on a role level and how to fix it on the role level. Because if you fix it on the role level, you have taken care of the user problem. What is permission explosion? Permission explosion is simply users having too much access than they really need for their day-to-day job. So why does it happen in AWS? The big question. Based on what we saw in the subset of our environment at Motive, there were 3 main reasons. And I'm sure you guys will be able to relate to that as well. Number 1, permission creep. There are often scenarios where the scope of teams within companies keep on changing. Engineers move from team 1 to team 2. And what ends up happening is, because of the scope or nature of jobs keeps on changing, you need access to new things as you move on in your journey or as the company grows. And what ends up happening is people acquire too many permissions, and the old permissions are never taken away, which leads to permission explosion. The second reason, temporary access. There are often scenarios where people need access to work on specific tasks or investigate an incident or some ad hoc request. And because of that, they add permissions to their roles. And these permissions are never taken away, which again leads to permission explosion. The third reason is it's very easy to grant broad access. And I'll use some numbers to put into some perspective here, and this might surprise you. Do you guys know AWS has over 350 resource types? And to each resource type, there are tens and hundreds of permissions that users can actually use. For example, on S3, I have a put object, get object. Similarly, for EC2 instances, I can attach a security group, I can attach a ACL. So there are different types of permissions or actions a user can perform on a resource type. And in total, there are more than 13,500 permissions in AWS. So just imagine how difficult it is for a security team or operations team to manage these permissions. How will they decide what permissions should be given to which role? And because of that, we end up giving broad access to simplify the management, and we compromise on security. And this leads to permission explosion. Now that we have learned the 3 reasons why it happens, let's see how we can measure permission explosion. Because if you cannot measure it, you cannot quantify it, how will you know if it exists in your environment? And if you don't know if it exists, how will you fix it? So we are introducing 2 new mathematical terms here, or you can say as units, so that we can quantify permission explosion. The first one is permission utilization ratio, which basically represents true utilization ratio of a permission in a role, which means how well a permission is used within a role. PUR, permission utilization ratio, can be calculated using 2 parameters: the frequency of use of a permission in the role and the number of users who use it. I want you guys to focus on both of these parameters. These are really, really important. Frequency of use is important because it will tell you how frequently users use that particular permission in a role. Because if a permission is used only once in last 90 days, then it tells you that it's not heavily used permission. This might have been given to actually get some particular task done. And the number of users is also important because it tells you how widely a permission is being used within a role. Let's say a role has 50 users and only 1 user is using a permission on a regular basis, then it is clear that that user is not doing something right. And the utilization ratio of that permission should also be very low. So that's why both of these parameters are very important to calculate PUR. Let's take a look at the formula. You take median of number of days that represents the frequency of use of a permission, and you multiply that with the number of users who have used that permission in last 90 days. Now the duration 90 days could be anything depending on you want to do 6 months, 1 year, but we will take 90 days for now. And divide that by the product of total number of days and total number of users. This will give you PUR. Let's do a sample calculation. So the role we are taking today is platform security. The resource is S3, R&D bucket. And the action is put object. Now if you remember, a permission is comprised of 2 things. The resource, specific resource, which is S3 R&D bucket, and the action, which is put object. So today we'll be calculating a PUR for this specific permission, which is named as S3 R&D bucket put object. Now some of the input parameters, the median number of days this permission was utilized in platform security role was 150. The number of users who use this permission in platform security role is 10. Total number of days is actually 365, and the total number of users is 42 in this role. So when you input all these parameters, you get the PUR, which is 0.1. What this means is the utilization rate of this permission S3 R&D bucket put object in platform security role is 10%. Now let's go into the second unit, underutilization ratio of a role, which represents proportion of the permissions within a role that are rarely or never used. The formula is you take sum of all the PURs for a role, and you subtract that from 1 and divide by total number of permissions. I don't want you guys to worry too much about the math, but let's take a look at the sample example, but after that we'll move on to how we can use these formulas to actually come up with the insights. But for the math right now, let's calculate a URR, underutilization ratio of a role. The number of permissions we are taking is 5. Let's imagine out of thousands of permissions we have only 5 permissions right now for platform security role. The PUR for each permission is in this array. We take sum of all the PURs and we put that into the formula for URR. And we get the underutilization rate of the platform security role for all the 5 permissions is 50.56, which means 56% of the permissions are not utilized effectively in platform security role. Now that we understand the math, let's take a look at our AWS setup so that we can understand rest of the content of this presentation. We have these 5 different IAM roles. Obviously, this is a subset, but this will be helpful moving forward. We have a QA role, we have a safety role, backend, embedded, and platform admin. These are the resource types we use in our company. And let's talk about the tooling now. What tooling we used to identify and reduce permission explosion in AWS. So it's very simple, basic day-to-day tooling that we use in our jobs as security engineers. We use Python as a scripting language. We use Google Colab as a Jupyter notebook. And we use Sigma.js as a graphing library. It helps us visualize the data. And we store the data in SQLite database. Talking about database, let's look at the schema. So this is the schema. There are around 6 tables on the left and then 1 big table on the right. I'll quickly go over the 6 tables and then I'll explain what is the master table. So we have an applications table. We have only one application right now, AWS, but as I said, you can expand this system to other applications as well. So here we store the applications, and then we store roles for each application in roles table. The users table have users for each application, and then you have resource types for each application in resource types table. For example, S3, EC2 instance, secrets, etc. And then we store what actions are available for each resource type in this table. And then in the end, we also have a list of resources. Using all these 6 tables, we create this master table called role permissions. And this is a table we use to do all the data analytics, identifying permission explosion, and how to fix it. I want you to focus on 3 fields in this table. One is accessible. This field tells us whether a permission in a role is actually accessible or not. It's a Boolean field. If platform security role can perform put object action in S3 bucket, R&D bucket, then this field will be true, is because the permission is accessible. And the next field is accessed, which basically tells us that in last 90 days, has the permission been really used or not? And the last field here is permission utilization ratio. So we calculate permission utilization ratio of each permission for each role, and we store it here. Sample graph, I would like to show you before we get into all the complicated graphs. This is a simple graph to show you that we use Python. We get the data from our database that we just discussed, and we pass it to the Sigma.js library. And with that, we are able to create these kind of graphs. So we will see what these graphs means moving forward, but I just wanted to show you how these graphs are generated. And we'll also share a GitHub repository towards the end, where you will get all this code available to you so that you can hook your data and start getting all these insights. All right, so let's see how we can identify permission explosion. So this is where we start. This is the subset of our environment at Motive. We are taking 5 roles right now. And we can clearly see that permission explosion is happening because there are too many permissions assigned to each role. But how can we say for sure that are these excess permissions or these are the permissions that people actually need? So what we did is we divided permissions into 2 parts. One is what permissions are actually used versus what are not used. And if you remember, we have these fields in our database, is accessed and is accessible. So using those two fields, we created this graph, and the results were actually surprising to us. Nearly 42% of the permissions were not even used once in last 3 months. So this is how we knew that, okay, something is not right. People have way too much access than they need for their day-to-day job. Now, how to fix it? Now that we know permission explosion is there, how to fix it? So this is our starting point, as I said. People have way too many permissions. We simplified that and we just started focusing on one role, QA. So this role has 786 permissions. And when we created red and green edges to basically differentiate between used and unused permissions, we saw that there are a lot of unused permissions for QA role. And when we take those off, we were left with only 476 permissions out of 700 something, which means we were able to reduce the number of permissions for QA role by 40% by just this one simple strategy, by revoking unused permissions. And when we did that for our whole system, we were able to reduce the number of permissions by 42%. So this is a pretty good result, but we wanted to dig deep and we wanted to actually go beyond further and reduce the permissions because we knew that there are still some permissions that are not effectively used. So this is our graph when we remove all the permissions that are not in use, right? So this is after applying strategy number 1. Now we focus on QA role again. So after applying strategy 1, we had only 476 permissions that were actually showing how many permissions have been used at least once in last 90 days. So if you remember, we have this field called PUR, permission utilization ratio, in our database field. Using this field, we revoked all the permissions from QA role where the utilization rate was less than 10%, which is 0.1. And when we did that, from 400 something, we were left with only 286 permissions. That shows the edges, right? Edges basically is like what permissions are assigned to a role, which is 40% reduction in the permissions for QA role further on top of strategy 1. So the combined result is actually 36% for the overall system, right? If you apply both the strategies, it is like you're reducing the number of permissions by 36%. So the combined result is this, 63%, right? So first one, second one, you apply both strategies and you're able to reduce the permissions by 63%. Let's go for another strategy. I would like to call out this is a bonus strategy. This may not apply to all the environments, but this is a very interesting one. And we'll have a pop quiz question based on this later on. So we have a platform admin role. This role, people in this role are responsible for managing the overall AWS environment, whether it is database, security, infrastructure, CI/CD, developer productivity, everything. We have 29 users in this role, and permissions per user is 75. And this is after applying both the strategies of 1 and 2, which is remove all the unused permissions and remove all the permissions that have utilization rate of less than 10. So we are left with 75 permissions for this role. Now the goal of this strategy is to actually reduce the number of permissions per user. So we knew that this team has gone very big. It started as 5 people who were working on everything in AWS, but now it has gone big, and people are working on some specific areas. Like 3 people are working on database, 4 people are working on security, a couple of people in developer productivity. So we knew that there are some pockets of sub-teams here, and they work on specific things. So we split the roles into separate sub-teams, level roles. And when we did that, we were able to reduce the number of permissions per user to 32 from 75, which is a reduction of 57% permissions per user. This was very interesting to us, and this actually is the case with a lot of companies that I've seen, that people have too much access because they are broad roles. So now the pop quiz question. When a company grows, the number of teams grow, should the permissions per user increase or decrease? Decrease? All right, everyone is paying attention. All right, yeah, so the answer is the number of permissions should decrease. And I'll reiterate, we saw this in our environment where our platform team was only 5 engineers. It grew to 29, now it's 50 engineers, more than 50 engineers, right? So people just keep accumulating permissions and their scope of work actually reduces. As the company grows, people focus on specific areas instead of, like in a startup, one person does everything, right? So the number of permissions should decrease as your company grows. So you should go back and check what's happening in your environment. It'll be interesting. All right, so now that we know how to fix it, let's understand how we can keep permission explosion away in our environment. So the answer is automated policy generation. So we create an automation script which will generate IAM policies, and this will run on weekly basis. And what this script will do is it will pull all the permissions for every role in our environment, and it will pull only the permissions that have utilization rate of more than 90%. Oh, sorry, the utilization rate is more than 90%, yes. So when you do that, you pass all the data, all these permissions for a role, and there is some regex pattern matching going on to create a AWS IAM policy. And then dynamically, you attach this policy to your AWS role. By doing this, what you're doing effectively is every week, you're taking away the least 10% permissions that are not being used away from people. So you're revoking the permissions for which utilization rate is actually less than 10%. And if you do that on weekly basis, permission explosion will not creep into your environment. So quick recap. We learned a lot today. Okay, so identifying permission explosion is actually a data problem. You don't need all the fancy tools to actually identify it. You just need to pull in the data from AWS IAM, put it into the database, use the scripts or use data science, Jupyter Notebook to build all these graphs, and you will be able to identify the patterns. Once you identify where the problem is, then you can update your AWS IAM roles or groups and revoke the permissions, right? So these are the strategies we looked at today. To fix the permission explosion happening due to permission creep, you just remove the unused permissions, right? Use those database fields and remove the unused permissions. To fix the problem happening due to temporary access, people request access to different things on an ad hoc basis. You use the parameter in our database, which is permission utilization ratio, and remove all the permissions to whatever threshold you want to set. Today, we use 10% as the threshold. You can use 5%. You can use 20%, depends on the company, right? But remove the rarely used permissions from the roles. And the third one is broad access roles. If that exists in your environment, just break the roles into smaller teams or smaller roles. The last one, but not the least, very important, use automation. Because if you do not use automation, the same problem will happen after 1 year, and you will have to do the same exercise again and again. So if you want to be really successful, develop automation to generate these IAM policies and attach them automatically to your IAM roles. Now, how to get started? Today, when you walk out of here, how can you use all of this? How can you implement these strategies in your environment, right? Simple 4 steps. 1, push the IAM data to the database, right? We will have scripts in the GitHub repo that you can use, and you can generate your own scripts as well. It's very easy. Just use AWS APIs, get the data, and push it in the database as per the schema. Use Workbench Notebook to identify permission explosion. The idea here is that use the data, try to understand what's happening. We have the notebook available in GitHub. You can use that. You can update that, whatever you like. But the idea is that use the data to understand where the permission explosion is happening. Now you all know how to do it. Generate new policies based on the findings in step number 2. And attach these policies to your IAM role. And last, automate the whole process. Otherwise, you will end up in the same spot. Cool. So this is the GitHub repo. The slides will be uploaded at Black Hat. You can actually go to this GitHub repo and you can look at the notebook, see the code, see the libraries, and see how to build all these graphs and how to identify permission explosion. With that, I will open for any question and answers. Otherwise, thank you. Let's take some questions.